Good morning and good afternoon, everyone. My name is Claude Tetelin, and I'm working at GS1 Global Office in the team devoted to automatic identification and data capture technologies. Let me briefly introduce myself. I joined GS1 more than 2 years ago, and before joining GS1, I was leading an RFID lab in the University of Marseille in the beautiful south of France. I was involved in many different research projects, always proposed by either solution providers or end users. And since these projects were funded by solution providers, I quickly understood that even if you propose technical improvement to make RFID more efficient, you have to keep in mind that the end user wants to rely on stable technologies and standardized solutions. This is not because they are afraid of innovation. In fact, they always try to create new services in order to differentiate from the competitors. This is more because, like any other technology, RFID never works alone. RFID is always a small part of an industrial complex processes. Therefore, even a slight change in the technology can have huge impacts on the entire value chain. So even if the role of a research lab is to invent new ways to improve the technology, you have to keep in mind that you cannot only propose disruptive innovation, and that you have to take into account the existing deployments and think about backward compatibility. Therefore, as a researcher, all your projects should be balanced between disruptive innovation and simple improvements. At the end, everything will have to be standardized in order to have a chance to be accepted by the market. And this is exactly what we are doing in GS1 because we believe in the power of standards to transform the way we work and live. So let's start with a very short presentation of GS1. We are an international and not-for-profit organization that develops standards for increasing efficiency, safety, and visibility of any kind of supply chain across multiple sectors. The entire set of standards is based on three following pillars: identify, capture, and share information between stakeholders. We serve more than 2 million companies around the world in 150 different countries. We are mainly known for the EAN UPC barcode that you can find on every single product in the retail industry. But we are also known to be the organization which standardized the RFID air interface known as EPC Class 1 Gen 2. How to build an efficient, open, and scalable supply chain involving multiple stakeholders from different sectors. In order to do that, you cannot rely on a single standard or on a single technology. First, you have to be able to identify a lot of different assets, products, or locations with different level of granularity. Can you imagine a single global issuing agency that can provide all the identifiers you need? Of course not. But you can imagine a standard that will allow you to build your own identifiers in a way that you will be sure that they will be globally unique and will not interfere with other identifiers. This is the purpose of GS1 standards for identification. Based on the GS1 company prefix allocated by GS1 to every kind of stakeholders, you can build your own identifiers depending you want to identify a product, a container, or a location. Second, you need to define different formats for these identifiers so that they can be carried by different technologies, 1D or 2D barcodes, radio frequent carriers, or electronic messages. You should also be able to encode additional information about the product, like a batch number, a production date, or any other business-related information. This is what GS1 proposed with the capture standards. You surely know one of them, the EPC Gen 2 V2 Air Interface Protocol, which is about standardizing the communication between RFID readers and tags. What is important to keep in mind is that all these different data carriers shall be interoperable, because not a single technology can answer all the different business needs. Furthermore, because in open-loop systems, everyone will not be able to read RFID tags, you will surely need to mix different technologies. This is all about scalability, because RFID implementation is not Big Bang. It's a long journey. Finally, you will need to leverage from share-related standards to access and share additional information about the different products. You will also need to describe all the different events that a product can have during its life, from manufacturing up to recycling. In order to do that, you need to agree on a common vocabulary. What's important to keep in mind is that if you don't use open and global standards, you will be either locked by closed-loop system or you will be locked by solution providers. To paraphrase Taiki Hono, the Japanese engineer who developed the concept of just-in-time for manufacturing processes, without standards, there can be no improvement. When doing research to improve existing technologies or developing new ones, you first need to think about the use case. RFID can be used in many different ways and for many different purposes. First, imagine a warehouse manager who wants to know in real time what's on the different shelves. He can benefit from RFID to uniquely identify all the different products and to easily make inventories. What's important for him is to be sure that all the products will be tagged, and since he is managing billions of products each year, the cost of the RFID tags is really something important to consider. He will just make use of the inventory commands defined in the Gen 2 protocol and only read the content of the EPC memory bank. But when comes the time to monitor the temperature of high-value products like vaccines, you can also consider the use of RFID. The tags will not only allow to inventory the products, but are intended to carry additional information like the batch number or the expiry date. And since the temperature is critical, you might also use sensor tags. This will help you during vaccination campaigns, for sure. The tag will be a little bit more complex, and the RFID reader will have to make use of access commands to read the content of the user memory bank. In that case, inventory speed is no more a KPI. Can you imagine two different applications using the same technology, but based on two different standards? For sure not. That's why a standard like Gen2 shall be flexible enough to allow different implementations. Furthermore, business needs may change over time, and RFID adopters could leverage from their investments when upgrading the solution. That's why you will find mandatory commands and optional ones. Mandatory commands are there to build a strong basis for simple implementations, and optional ones are dedicated to more complex business needs. As a consequence, you will be able to pay for what you really need and will be able to upgrade easily whenever you want. So how to improve the technology in order to solve the different business needs? There are many different ways because RFID is made of radio frequency electronics, identification, and communication protocol. For basic needs like just counting items, the major trend is to make RFID tag cheaper and cheaper. You can reduce the size of the identifier so that you will reduce the memory size, but keep in mind that there are more and more tagged products, and we need to ensure unicity. You can also think about printed electronics to create RFID tags on demand, just like when you print 1D or 2D barcodes on a box. This is a very promising research area, but keep in mind that the reading performance cannot be sacrificed. When comes the time to make use of sensor tags or tags that carry more than just an identifier, you can think about improving tag selection so that the end user will be able to focus on the tags of interest. For example, you may want to only read items that have a particular batch number in order to improve your product recall process. You can also think about changing the air interface protocol and ask the tags to backscatter the content of the user memory during the inventory round. This will prevent the end users to access every single tag after the inventory in order to access additional information. You can also improve the data rate by using new modulation schemes so that reading tags will take less time. Whatever you imagine, and I'm sure that you have a lot of very good ideas, you have to keep in mind what I said before. RFID implementation is not a big bang. It's a long journey that the end users who make the investments need to be sure they can accomplish. Backward compatibility is not an option, and neither is compatibility with other data carriers. I understand it could be somewhat frustrating to not only take into account the laws of physics, but also the laws of the end users. But this is the only way for you to have a chance to see what you invent on the market. End users will deploy RFID if they are sure that the technology will change smoothly. Otherwise, they will always postpone their investments, waiting for the technology to be stable enough. Of course, this does not prevent or improve the technology, and here are a few examples of improvements that GS1 members are expecting in the next few years. Let's talk about the RF link. Of course, tag sensitivity is a key factor, not only because a better sensitivity can increase the reading distance, but also because it increases the read rate at a given distance. Together with the tag sensitivity, the reader sensitivity has also to be improved, otherwise the maximum reading distance will be limited by the reverse link. The tag backscattering efficiency is another key factor. In order to avoid the tag overdrive, this backscattering efficiency shall be as constant as possible and shall not change with the amount of power received by the tag. Finally, tag performance is one thing, but what is very important is the tagged item performance, because tags are always associated or attached to products. The tag item performance protocol has to be improved in order to take into account new RFID applications and ways to implement readers. For example, smart cabinets and overhead readers are more and more used in many different sectors like retail, healthcare, and manufacturing industries. A second set of improvements are linked to the tag design. End users require us to have smaller and smaller tags in order to be able to embed these tags directly into products. For the apparel sector, we see more and more end users searching for tags that can be embedded in textile products for consumer engagement and for circular economy purposes. For the supply chain, printed RFID tags could help in midstream tagging when manufacturers are not ready for RFID implementation. As always, there is no one tag fits all, but it could be interesting to design tags that are less sensible to the environment. The auto-tuning of RFID chips is interesting because new antenna designs could help answering the business needs. As everyone is talking about IoT, many end users would like to make use of RFID for passive sensor networks. Energy harvesting or small batteries can help implementing passive sensor networks that could be interrogated using a simple RFID air interface. RFID for location purposes is also of interest for many sectors, even if there are more and more other competing solutions. A last topic I would like to raise is the question of product authentication. Ownership transfer is more and more requested by consumers who take care about sustainability. They just want to be sure that the product they purchase is genuine. Creating crypto suites that are efficient enough for such application, but that does not require too much resource, is something more and more required by the market. In conclusion, I would like to say that even if GS1 can be seen as a standard organization which focuses on data sharing processes between business partners, the research trends in RFID is something that is of great importance for us and our members. That's why we set up a partnership with 6 different universities in the US, in Europe, and in Asia under the Auto ID Lab umbrella. Of course, this does not prevent us to set up other partnerships with laboratories especially working on digital signature, blockchain, artificial intelligence, big data, and of course, RFID. So thank you so much for listening to my presentation, and do not hesitate to come back to me or to GS1 should you have any question about what we are doing with RFID.